So, here we have some problems on the angle between two curves. So, we in our last lecture we discussed that the angle theta between the two curves is given by cos theta equal to G11 into du1 over du2 delta u1 over delta u2 plus G12 into du1 over du2 plus delta u1 over delta u2 plus G22 equal to 0. So, where du1 upon du2 is the direction of the first curve, delta u1 upon delta 2 u2 denotes the direction of the second curve. So, this condition in short says that G11 into the product of the direction plus G12 into the sum of the direction plus G22 must be 0 for the curves to be orthogonal. So, now based on this information, let us look at these problems. So, the first one is prove that on a surface whose first fundamental form is this. The two curves given by these two. So, these are the differential equation of the two curves which are drawn over this surface. So, what I will be doing? I will be computing the direction of these two curves. In fact, this represents one family of curve, this represents another family of curve. You pick one curve from here, one curve from here and see what are their direction. So, the direction of the curve. So, this is exercise number 1 which I am taking up first. So, the direction of the two curves, let me denote the direction of the first curve. This is curve number 1 and this is curve number 2. So, direction of the first curve, direction of the first curve. And instead of calling it du1 over du2, I will call it lambda. See how much is du1 upon du2? It is minus times under root g. Okay. And the direction of the second curve is, let me call it mu, that is simply under root g. Okay. G11 here, if you look at the first fundamental form, you can tell me G11, G12, G22. So, look at the first fundamental form, that tells you G11 is 1, G12 is 0 and G22 is simply G. In bracket u1 u2 means just this much, D is a function of the two parameter u1 and u2. Now, see G11. So, consider G11 into the product of the direction, that is lambda into mu, plus G12 into sum of the direction, lambda plus mu, plus G22. Let us see how much it is. Okay. So, G11 is 1, lambda into mu is minus g, under root g into under root g is g, plus G12 is 0, 0 multiplied by anything is 0, plus G22 is g, and that comes out to be minus g plus g, which is 0. So, that proves that yes, these two curves are orthogonal to each other on the given surface. So, this resolves the first problem. Okay. Now, if G12 is 0, then these curves may not be orthogonal. No. But for parametric curves, G12 is the parametric curve of the surface are orthogonal. Okay, this is an important point that you have raised. What G12 tells us? In fact, G12, if it is 0, the parametric curves over the surface will always be orthogonal. So, in fact, before discussing more problems, let me elaborate how this happens. So, let me discuss first the angle between parametric curves. Parametric curves. So, parametric curves are 2 in number, 2 families of curves in fact. So, for u1 curves there are 2 types. For u1 curves what happens? u2 remains constant, and this would mean that du2 is 0. When u2 is constant, its derivative will be 0, and for u2 curve u1 is constant, and this will imply, because the derivative on the first curve you are denoting by d, differential along the second curve you were denoting by delta. So, I will write down rather delta u1 is 0. Now, look at the formula that we had for the curves